This is the Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hello, I'm Lee Gordon, and it's Wednesday, July 3rd, 2024. Welcome to the Math Map Book Club, where Kirsty Gilpin and I discuss lessons each week from our math curriculum for families with students enrolled in classical conversations communities. We're currently in our summer session and working through the curriculum by dimension rather than by lessons, so we can discuss resources and strategies in math education. And as a little side note, tomorrow is July 4th, which is where we celebrate our Declaration of Independence, but it was actually signed on July 2nd. And then in July 3rd, somebody said that we should tell somebody. So July 4th, they made the announcement and had the public celebration. So we're off by 2 days because, a bunch of men put that together and now organize their calendars are. So welcome to the Math Map Book Club. Kirsty, what's up today?
Well, we are continuing our journey through the Quadrivium and looking at our dimensions and just how that matches up with the Quadrivium and prepares our students for further studies. So as we do every week, we take a look at where we are. And so we are in that third dimension looking at astronomy, and we call that our human space. These are the 4 lessons that are available. We have digits, fractions, and complex available for those of you working at home. So before we jump into talking about astronomy and the Quadrivium, are there any questions anybody has brought this week? All right, well, we will go ahead. Just a quick reminder through these few weeks how to access those parent forums. And one of the beautiful things about the Math Map is that we are making it possible to have a unified conversation. And we've talked about that quite a bit, that no other curriculum, right? No linear curriculum is really conducive to having everybody working together, right? And traditional schools may claim that, but we know that some kids zoom ahead and some kids get left behind because going a lesson a day doesn't allow for that flexibility that our families need to tailor curricula to their students. And so the Math Map was really designed so that families could work together, parents could take ownership of math education and lead that in their families and meet the needs of their students. And not only does that create unity in the family and unity in the challenge classroom, but it creates unity throughout our communities and our global community of CC as well, so that everybody in CC can be working on the same math concepts each week and take that conversation to the forums. So right now it may seem like the forums are a great place to ask questions and get answers, but it's also a way to participate in that conversation with other parents. So just a reminder that you can go to the forums and on CC Connected, choose your role and then jump in. And Babs and Shauna have shared that I Have Questions is a great place to get started with the Math Map in the forums.
Oh, thanks. There's so much that we have available.
We do. There is a lot. And it's a good time to remind everybody that just because there is a lot of support and resources out there, there is no expectation that you use all of them all the time. And I know some people have said, oh, there's so much, it's overwhelming. Pick and choose. Booklets, everything you need to be successful each week is in the booklets. And then pick and choose the things that are going to add to that, not the things that are going to overwhelm, because there's a life that's available to use those resources. So as we've been talking about the Quadrivium, we've talked about arithmetic, that's really that study of numbers. Then we talked about geometry, the idea of numbers in space. And today we're going to talk about astronomy, which a lot of people call numbers in space and time. And I like this idea that I found as I was doing some research, that it was the mathematization of the heavens, that as people were observing the stars and the moon and the sun, right, they noticed irregularity, they noticed patterns, and so they were able to put numbers to that, and create these mathematical ideas that explained what they were seeing. And so they were really trying to explain, right, how does and we still do when we think of looking upwards as astronomy, right? Just as a reminder, that includes Earth, right? It's one of the planets. But as we look upwards out and we look at the moon and the sun and the stars, right? Well, astronomy today is still explaining how all of those pieces move and interact with one another. And they're doing so primarily mathematically. That's one of the things that we know predict where a planet should be, because they know mathematically that there needs to be some more variables going on, and they'll say we think there might be a planet there. I want to point out that it is extending through the universe, right? So when it's all of it. It is all of our known creation, our entire space. When we think of astronomy, it's not just our little piece of it, but it's looking for those patterns that work through the entire space. And historically and today, they're describing, astronomers are looking to describe and predict motion. So that's that piece of time that pulls in, right? So space and then motion within it, and that's the time piece. Anything anybody would like to have say about astronomy in general?
I was going to stop you, Kirsty, because Crystal asked about a question I answered on the chat. And this occurred to me as you're speaking. Is there a way you can see people's hands up so you can know there's questions, or do you need me to keep an eye on that?
If you could keep an eye on that, that would be great. I don't, because I only see a few people at a time.
Okay.
So.
Okay, so I just wanted to make sure people know we really are here to answer your questions, and that's why Kirsty at the end of each slide takes a breath, and you can change the topic if you need to express the answer. So are you okay with things I said, Crystal, or do you want to elaborate on it? Give another question. Basically, she wanted to know, it's a good question. Why are there some fractions in the naturals? If you look at it, all we're doing is matching a simple fraction to a simple image, because we want them to be having some fraction practice and just reading and naming, like what's half of a pizza and what's half of a chocolate bar, what's half of a circle. But they're not going to do any calculating with it at that level at all.
Thank you.
Okay, so back to your question. Comments, anybody on astronomy?
Percy, did you say that? So you're saying motion, I mean, astronomy is shapes in motion. So you're saying time is in there as well. Did I hear you say that?
Yeah. So usually when we think, when we're thinking about these ideas and we bring time in, there's usually this sense of movement or motion, right? That there's some kind of change. And we oftentimes think of time being a bridge between dimensions, right? So if I have a point, just one single point, and it moves, well, if I stay in 0D, it can move all over the place, and I'm really oblivious to that movement, right? Kind of like being on the Earth, there's no sense that I'm moving through space right now, right? If you ask me, I'd say, yes, I'm stationary. Well, I'm stationary on the Earth, relative to the Earth, but I'm actually in motion, right? So in my 3D awareness of my own little space, I'm not moving, but we know that truly I am. So it's the same idea. If I'm just in 0D, there's a point, right, isn't aware of its movement. But if I'm external to that point in a different space, I can be aware of its movement. And in order to describe that movement, I need at least one more dimension, right? I need the first dimension to describe how I went from one point to another point. To measure that distance or to give a direction, I'm going to need another dimension. Similarly, right, if I have a line, if I'm on the line, I may not know that it's moving. But if I'm external to that, again in 2D or 3D, if I'm external to that and that line moves, then now I need 2 dimensions because I need to be able to describe how that line has moved off of itself. And then that pattern follows through. So that idea of time, things changing in time, gives us this idea usually of movement, not always, right, but usually of movement. And then that helps us to have this bridge from 0D to 1D to 2D and so forth. So if you think of our 3D space, right, we're in our 3D space and it's stationary, right? We can't imagine our universe, right, go out to the very farthest reaches, and then 3D space is truly infinite. So it goes beyond that. We can't, where would it move to, right? Well, in 3D, it would not move anywhere. We are completely oblivious to that. If we're in 4D, right, then now maybe there is a direction in which our space could move, right? And so there's maybe a movement of our space that we're unaware of, but if we could be in 4D, we would see it. And so that's that dimensional pattern that we keep playing with over and over and over again. And time helps to give us a way of thinking through what might it look like to go from one dimension to the next. That help?
Yes, thank you.
It's a big thought, takes some more time.
Why is it that we've quit studying astronomy as a basic math or science?
You asked why? I missed a word in there.
Yeah. Why why has it fallen out? Like, why don't we really
Well, I suggest
study astronomy in that anymore? Is it physics has kind of taken over that movement of things, or is it just something that we find that we've mastered so we don't need to study?
so. Kirsty's going to address it more in another slide, but from a different angle than what I'd say. I would look back to the 1960s and the progressive era where high school came into existence. And that's also when we dropped reading Shakespeare. It's when we stopped doing Latin. It's when we stopped studying astronomy. Anything that's real kind of got pushed aside. And so, why did that happen? I don't know that I could give you enough evidence, but I would say that in general, the practical was the only thing that was going to be useful to that high school student. And before that, if you were that age studying these subjects, you were actually at a college where it was very intentional scholastics, not compulsory education. So a lot of just different things changed in the 50s and 60s when we started introducing high school to the curriculum. But Christy has some more philosophical reasons we'll be getting to.
Yeah, I was going to say, I think also too, we need to remember that the quadrivium historically was, and where we've got this high school that sort of is this weird, because it sort of overlaps maybe what was historically the quadrivium and what historically was the trivium. And so where is that? And we're, as homeschoolers, we're kind of keeping it more in that trivium, right, where we're preparing students to hopefully go off and look at that quadrivium. But then we also know that in college, right, college used to be you went and you got your liberal arts degree versus a practical degree. But as Lee was, alluding to, in the 60s, especially with the space race, things started to change. We started getting these more technical and more specialized degrees. And so we don't necessarily have generalists anymore, right? And a generalist education would have done arithmetic, astronomy, geometry and harmonics. But now that subjectization of our education also has led to this. So now it's reserved for just those few instead of for everybody. And I think the opportunity of the classical educator is to bring that harmony back. So each week I've been contrasting sort of some ideas behind what the ancients might have thought of when they thought of astronomy, and then sort of some of the modern astronomy. Right. We've talked about this a little bit, that the ancients were looking to understand the relationship of Earth to the heavens. right? That where do we fit into the idea? And some of that was the motion, right? We also know, right, through mythology that they were trying to come up with other ways, not just math, of other ways of explaining those heavens. But as they looked at time, especially on the practical things, right? But the seasons, right? When do we plant? When do we do different things? And then even using the sun for surveying and navigation, right? That could pull in some that I didn't put there. But that early philosophical bent was really trying to understand, just as we've said, all of these things, right, came back from people trying to find unity in the universe, even if they didn't know that that was God. And that's still what they were doing with astronomy. Now, modern astronomy, when you think of just the pure theoretical astronomy, a lot of times it's, how often do we see stories that, we found water on Mars, or we're going to find life somewhere else, or they're trying to discover the origins of the universe, or we just want to go and see what's out there, right? Exploring in astronomy. I think that a lot of us would disagree with the first two of those because we know that God created the earth uniquely. He created man here on earth and the heavens. We'll talk about why they're there in a minute, but it wasn't lots of other life forms as be in science fiction literature. And we also know that God created our universe. And so we don't need to go and chase down the origins. I always think, does that matter, right? How far back I go, there's always well, where did that come from? That, right? They're always trying to figure out how the universe might have started in ways that are a lot less plausible than believing in a creator. Of course, in an applied sense, there's space travel, right? There's satellites, there's experiments that they're doing with weightlessness, what happens, right, if we do different things up in space, and sort of modern astronomy that's out there. So we see kind of there's the astronomy piece is amazing when we look at it through the lens we're going to look at it through, but there's room for people to kind of go off on the fringes if they don't have something keeping them grounded.
I think it's, we're reminding ourselves about time with the word astronomy, time and space. But we forget that time and space and the seasons that it generates by the motion of the planets. That's why elephants migrate. That's why weather changes. That's why the polar axis magnetic field is messing up airplanes today. Right? And we forget that all that things that are up there affect us down here. And so what we're hoping to do is expand that conversation to know that we are actually part of the universe, even though we have a hard time getting off our own planet.
So let's talk about what is it, as Lee just, what is it when we think of classical astronomy, right? What is it that we want to study? And so I always come back to Psalm 19:1. And all right, every Foundations parent should know this, right? So what is Psalm 19:1?
Foundation. I'll let someone else say it. I don't know one thing.
Heavens declare the glory of God. Skies proclaim the work of his hands.
That's it, right? I don't know why, to me, that's like one of the things that stuck with me the most through Foundations. And I'm just reminded of that, right? Every time I go out and look at the stars, right? That the purpose of all of that wasn't to have little green men out there somewhere, or life here, or whatever, right? All these things that science fiction people think that there's all these stars, there must be life. Well, God says that the reason that there's all of these stars, right, are to proclaim his glory and his majesty. And so when we think about where we started in 0D, and we talk about the importance of understanding nothing, right, that God created from nothing. And so every single year, it's important for us to stop and go, well, what really is nothing. Well, the other end of that, the idea of infinity, the closest that we can get to seeing infinity is looking up and seeing the heavens, right? And to look up and go, oh, right, that this is the glory of God. These are the hands. And so he is constantly pointing us back to his majesty and his power, so that when we become overwhelmed with the challenges of life, we can look up and go, wow, God made this. He made this to remind me of how powerful he is. And so as we continue to talk about our goal in the Quadrivium, right, we've talked about the fact that the ancients, they wanted to find this unity. They wanted to find this wholeness. We know that unity and that wholeness is embodied in God, right? And we look for him, truth and beauty and goodness. And we look for him, right? When we look for some of that, we see that in the stars at night, right? As Christians, it's an opportunity to look at the expanse of the universe and catch a glimpse of the grandeur of God. So we're also interested, right, in time. We're also interested in being able to navigate space, right? So there's practical applications of astronomy that interest us as Christians, right? And we know that God created, right? He put the seasons, right, into motion. And so he's put time into motion. So we want to understand what he has created and the rhythms of life that he has created. But we also want to, right, just be encouraged by his majesty. So before we talk about how this matches into the math map, does anybody have any questions or comments, things they'd like to share?
See, years ago when I was learning about the harmony of this or the spheres, and it was like probably, I don't know, it was a long time ago. And I remember going to sleep asking what would that be like, because I had read a book that talked about how if everything, we're so used to hearing the motion and the sounds that it's like background noise to us. And so I went to sleep really kind of frustrated with that idea, and just like, God, what does this mean? And what would it sound like? And what does this mean? What do I do with this information? Well, anyway, in the middle of the night, I was asleep. Shortly after I'd fallen asleep, the AC shut off, the electricity shut off all at the same time. And if you've ever experienced like a whole neighborhood of electricity shutting off, it's like boom. And you awake startled because the whole house, everything, there's just silence. And all I remember thinking is, okay, God, that's what that might feel like. So if everything just shut down. And it was just a really good reminder that he is always working in the background.
Just for you.
Mm-hmm.
Anybody else? Oops. All right. Well, when we look at the math map and astronomy, you may have questions. So I noticed that Donna had put in the chat that we had as it built, right? You could look at, we have numbers with arithmetic, then we had numbers in space with geometry, then you could have numbers in time with harmonics, and then numbers in time and space with astronomy. So some people go in that order, where we're putting astronomy before harmonics, and that's intentional. One of the reasons why we associated astronomy with 3D is because that's the space that we inhabit, right? This is where we live. And so when we think about understanding our space well, it's not just our earthly space or the things that we can put our hands around, but it's all of space, right? It's out to the farthest reaches of the universe. 3D actually extends beyond that, as I mentioned a moment ago, right? So there's a great example of how, right, when we think of things that are infinite, it's really hard for us to conceptualize what that means, because everything that we know is finite. And so the biggest possible thing we can think of is the universe. But there's an edge to the universe. Right? Our universe is bounded. It isn't infinite, but mathematical space is infinite. And so somehow it goes beyond our 3D, or beyond our universe, right? Beyond our known space to this mathematical space. So that I always think is something to sort of sit and ponder a little bit, right? What's beyond our universe, even within 3D space? Things that we're going to talk about, we're going to talk about orientation in space. And so when we think about orientation and location, we're going to be talking about how we have 3 axes, or we can use spherical coordinates in order to talk about where we are in space. We're going to talk about different figures in space. So we're going to talk about surfaces, lines, those would be things that are open as well as things that are closed. And that's what most of us are familiar with, right? So the things that we can see and hold on to are closed figures, right? And the shapes that we're going to look at are going to be, we like closed things because they're things we can conceptualize. We're going to look at how we can arrange things and study things in space, and especially in our 3D space. And it's in our 3D unit where we're going to take a look at time. And so students every year are going to be reminded to go back and look at time and how time is measured here on Earth. So those are the things in the math map that are sort of aligned with this idea of astronomy, right? So we're not necessarily going to be speaking so much about the stars. We're going to be looking at math that would help us to communicate about space. Anybody have any questions about that?
I think maybe a clarification, Kirsty, would be that we've got everybody set up in 3D to be ready to study time, but we don't actually begin the motion portion of it until in 4D, because time replaces X, Y, Z, W as its 4th dimension. So that's when we start actually doing calculations.
Yeah, in 3D, we're going to talk about time in terms of itself as a measurement, versus in 4D, we'll look at time as a variable. So we need to have the language of time and the conversion factors and naming and defining time before we can actually use it. Yes.
Christy, I wonder if you could just, there are 4 units in the 3D part. Could you just like very briefly define like open shape, solid shape, locations and populations, just and how that sort of fits? That would be helpful.
Yeah, so that first one, open shapes, really is that orientation in space, right? How do I use my coordinate systems to talk about where I am in space? How do I orient myself? How do I describe a single line in space? How do I know where I am? How do I find intersections in space? Those are our open spaces. Then our figures in space, right, that's we're going to look at those really in that solid shapes unit. That's where we're going to look at our solids like spheres and cylinders and polyhedra, and we're going to look at the mathematical properties of those solids. Then we have 2 units. We've got the unit that's called locations, which is going to not delve too deeply necessarily into 3D-ness, because that gets a lot, although we're going to use a lot of 3D examples. But locations is really emphasizing the idea of how we know where we are by looking at the intersections of different sets. And so, for example, latitude and longitude are my favorite example. And we call it's locations, but it comes from the Latin word locus, right? And latitude and longitude, if I know where, if I said I was on the equator, well, you know that I am somewhere at 0 degrees latitude. So somewhere on that circle, that great circle that's going around the middle of the earth, but you don't know exactly where. But if I was to then say I'm on the prime meridian, right? Well, if all you knew that I was on the prime meridian, now you know where I am, right, on this circle. If you know where I am, right, if you know I'm on both of those circles, well, you know where where they intersect, that's where I am, right? And so now you've got two sets, right? The set of latitude and the set of longitude, and where they intersect gives you one specific location. And that's what we're going to be looking at in locations. Isn't necessarily latitude and longitude, although that's an example of it. But if I wanted to, right, where can my dog run? If I have a leash that is 4 feet long, right? How far away from me could they get? Right. And we instinctively can say, oh, well, it would be 4 feet, right? Because they can go all around. But that's the idea of locations, is being able to say, based on these criteria, where am I located in space, or what are the boundaries of my location in space? And then our last unit in 3D is going to take a look at problem solving and also statistics. So we're going to look at data arrangements. We're going to look at when we want to study things that are happening in our real world, how do we do that, right? Because a lot of times we have more information than we need. And so we can use statistics to help us gather information. We're going to talk a little bit about that. We can arrange that information in graphs in different ways. And then we also are going to use our common topics and our canons of rhetoric to be able to go through and formulate what our question is, and then look at the data we have in order to be able to answer that question. And so that lesson is pointing towards that. Does that help?
Sorry. Yes, I'm sorry, my camera. Yes, that was very helpful, just to kind of get an overview of how we're incorporating 3D. And so like the latitude, longitude, do we also do an altitude? Do we introduce those 3 elements in that one, or is it just stay with the latitude, longitude?
We do,
That's just
right. So latitude and longitude is an example in that, because it's something most of us can think about.
Yeah.
And here's the simple question. When we talk about our location, why do we usually not include our third dimension?
Yeah, because we're on Earth, then yeah.
Exactly, right? If we said the radius, so and it's a little bit different to spherical coordinates, because spherical coordinates wouldn't be measured from the equator up, they'd be measured from the sort of the axis down. So it's a little bit different, but it's still this idea that we have 2 angles and a radius. But when we think about the surface of the Earth, if we're on the surface of the Earth, we know it's not a constant radius, but we treat it as such, right? We assume that if you're on the surface of the Earth, you're at 0. And it's only when we're in an airplane or other sky type of thing that we would include our altitude, because now we're not on the surface. Or if we're diving in and going under the sea, right, or going below ground, then we would talk about how far below, right, how far towards the center of the Earth we're going. So we're only going to use that altitude measurement when we're not on the surface of the Earth.
Well, actually, let me add an example we use it all the time is if you live in a city. So I might tell you to go north so many blocks, then east so many blocks, and then take two floors up to the office I want you to go to. So it's interesting because people that live on one floors don't. People that live on many floors do, actually. And you guys will even say go upstairs to your kids. So that's when they naturally are changing their altitude. So I just want to bring that up so that you point it out to children so they get familiar with it.
Other questions? So remember, we're not in the math map. We're not really teaching astronomy, right? That we are not, we are a trivium curriculum, but we are preparing our students to be able to go and dive deep into the quadrivium. And so we're giving them the tools and the language to be able to go and dive deep into astronomy in further studies. So that's what we're trying to do in our 3D lessons, is really, right, point to these big ideas, right? Why would we study astronomy? What is it what's the purpose in, but the skills that they're going to get are going to be the skills needed to study down the line. Just a reminder that the digital resources are out there and available to you for digits, naturals, and fractions, as well as our printed lessons for complex. Lee and the team are working hard to get digits, integers, fractions, updates to complex and monomials ready for next year, as well as the digital naturals, decimals, rationals, and reals. This year we've got 4 levels. Next year, as you can see there, we're going to have 9. So we're excited about that, and they're working hard on that.
Well, actually, well, 5, well, 4 new ones, including complex would be 5.
And then we just wanted to share, so we've got lots of support. Don't forget that there's the companion, the CC connected forum, the community and your tutors, and email. With a short note about the companion, it's not live yet, but I have been working on expanding our list of abbreviations and symbols. That's been a commonly requested item. So we're going to go from 1 page to nearly 3 pages full of symbols for people who have been looking for that reference. That should be live in the next couple of weeks. And
We're doing that. That was a lot of hard work she did quickly, but people are asking. And so once again, she's doing her best to hear what you all are sharing. And it's the folks on the book club that we listen to the most, because you guys have been so faithful. And I just once again want to thank you for coming week after week.
And so speaking of the book club, we wanted to let you know what was happening in July, and then what our plans are for the coming year. So this week we talked about 3D. Next week we're going to talk about 4D, and we're going to wrap up our individual approach to the quadrivium by talking about harmonics. July 17th, we're going to, I put down quadrivium conversations, so that we can just sort of think really broadly that week about how these 4 different pieces of the quadrivium then come back in to inform us and help us to understand more about God. And so that will be July 17th. July 24th, we are going to ask you to help us practice table talks for the practicum in 2025. Lee has some things that she would like to do that week, and some things she's been planning. And so we're gonna try them out with our book club friends. And then on July 31st, we are going to start back with our weekly lesson, going through 1 lesson per week. And we decided that what we're going to do is we're going to use the in-community outline as our guide. And we've had a lot of people that are like, oh, we just wish there was a video of you going through this in a class. Well, of course, every group of students is different. And some weeks we see that on the book club, right? Some weeks there's lots of chit chat, other weeks there's less. Every time it's different. So there is no model for what an in-community conversation looks like with the math map. We really want to emphasize that, and we don't want to create a model that makes people think, oh, that's what it has to be. So instead, we thought that we would use that outline with our book club for 2024, 2025, and each week we will and give you a sense of what this could look like if you were in class. So we hope that that will be helpful to tutors who are perhaps looking for some examples of how this might go, and for parents who are wondering what their students are doing in class, or parents who wonder what will this look like, or parents who maybe have older students and are going, well, my student's not getting this in class. What would I do at home with my students to replicate what they would get in community? So there's a lot of different groups that we're hoping this is going to encourage and equip by doing this. But again, not by providing a model class, but so hopefully everybody can see that every time it's going to be a little bit different, and that will be encouraging. So that will start July 31st. It will be, and we'll start with lesson 1, ex nihilo, and go from there.
I'm assuming that's in the complex.
Yes. Well, we will.
Okay, it didn't say anywhere.
I will use the complex resources, but just like our students in a challenge community can be on any level, right? They could be in any domain. So at home, you might say, hey, we're working through the naturals. Well, you can still show up and participate in the conversation, even if you have the naturals booklets, right? If you're using the fractions booklets or the digits booklets, you can show up and participate in the book club with those booklets and see what we mean when we say, hey, you come to community and the tutor is going to have the complex, but you as students can use the materials that your family has chosen to use at home to do that best. Now this year, every student is to have the complex because that's the only printed level. That's the only level where you had the charts and the I-squared pages and so forth. But in terms of the lesson pages that you're completing, you can use any of those levels. Does that help clarify? All right. Well, that is the end of what I have for you today, but we have time, so I'm happy to answer any questions that anybody might have. And this is your best chance. Lee is going to be gone for a couple of weeks. She is going to the Global Home Education Conference. And so if you have questions and you want to make sure you get Lee's input, today is your chance, or wait till the 24th. So.
Sounds like they're all doing summer. So thanks for coming.
It's a good day to finish early. Everybody go and enjoy your holiday, and